Right, we're going to rearrange this into this format where A and B are constants, and we want to find the value of A and the value of B. Now basically what we're being asked to do is to complete the square. Now the method for completing the square is we always get x minus half the value of the coefficient of x inside the brackets, and then we can work out the outside bit. So let's just do that bit first. So we're going to write down x squared minus 8x minus 29. Remember, I'm going to halve this. X minus half of the 8 gives x minus 4 squared. Reason doing this is because actually if you always do, let's put this just down here, x minus a squared, every time you multiply that out you get x squared minus 2a, lots of x, plus a squared. Now even if this is plus a, you'd get a plus there and you still get a plus there. Notice you always get a plus a squared from this. So therefore this value is always half that value. So you want to get the right number of lots of x, just halve what you got there and put it in the bracket here. That's what we've done there. Now we know that this will give us a 16. So easy way to remember what to add on to the end, always take away whatever this is squared, so take away 16 and then add on the number here. So add on the minus 29 to get us the number we want on the end. So our final answer will be x minus 4 all squared minus 16 minus 29, so that's 3945. So therefore A will equal minus 4 and B will equal minus 45. So let me just review that for you. Bit of highlighting. So this bit here squared, if I square that minus 4, I'll get 16. So therefore I take away the 16 to negate that. And then all I'm having to do is to add on this number, which is the minus 29, on the end. So if you get into the habit of always automatically taking away this number squared away, so minus 4 squared is 16, take it away, and then adding on this number, you'll always end up with the right number on the end. Alternatively, if you can't quite remember all of that, you could just multiply all this out. So you get x squared minus 8x plus 16, and then you've got to realise, what have I got to get from 16 to minus 29? Well, I need to take away 45, and you could do it that way. Now, just say you can't remember the method of completing the square. There's another way you could do this. You could multiply this all out. So let's just do that. Let's multiply ax plus a all squared. So you're stuck in an exam and you've forgotten how to complete the square. We'll just multiply this out. So x plus a squared is x plus a times x plus a plus b. Now we're going to use our little bit of FOIL to help us remember how to multiply this out. First two things gives us x squared. Outer two things gives us ax. Inner two things gives us another ax. Last two things gives us an a squared plus b. So we can see we've got x squared plus 2ax plus a squared plus b. So straight away the number of x's is 2a. Well, we've got minus 8, so minus 8 must equal 2a. So therefore minus 4 must equal a. Now if you know a equals minus 4, we've got effectively here 16 plus b. And 16 plus b must equal the minus 29. So minus 29 must equal 16 plus b. Take away 16 from 29 and you get minus 45 equals to b. And we can see we've got exactly the same answers as we had before using this method. So if you forget how to complete the square, you can work it out just by multiplying out the letter bits and then matching them up. This is called equating coefficients. The coefficient of x is how many lots of x. We've got minus 8 lot here and we've got plus 2a lots here, and we're making those equal to the same, and the number on the end is minus 29, the constant term, and we've got the constant term, there's no x's here, a squared plus b, that must also equal minus 29. Let's go on to part B now. So hence or otherwise show the roots of this. Well, you could do it by quadratic formula. I'm going to use the hence to show you how to use the hence in this case. So we're going to replace the always write out the question, because it's quite important. If you make copying errors, then you can get credit for them in the exam. And I'm going to replace that with the thing I found up here. So I'm going to replace that with x minus 4 x squared minus x minus 4 squared minus 45 equals 0, and use this to solve the quadratic. Because now the x is, you've got one x on its own, we can just use our normal algebra methods of getting x on its own and solving it that way. Add 45 to both sides, so we get x minus 4 squared still on this side equals 45. Now we're going to square root both sides. Now we need to remember that plus or minus the square root of 45 will equal this, because when you square a positive number, it will become positive. If you square the negative number, it will become positive. So you square plus root 45, you'll get 45. Square minus root 45, you get 45. So don't forget your plus or minus. And then we just add 4 to both sides. So we got 4 plus or minus square root of 45, which is not quite the answer we're looking for here. We want c plus d plus or minus d root 5. Well, let's see what we can do with that. 45 is the same as 5 times 9, and 9 is the same as 3 times 3. So we can see that square root of 45 is 5 times 3 times 3, and everywhere you have a pair, you have a square, so we can take that out. So we can take that out of the square root, and it just leaves us the 5 here still to be square rooted. So that 5 goes there, and these two root 3's, which were here, end up there because they've now been square rooted. Okay, and so our final answer is going to be 4 plus or minus 3 root 5. So if you want to find c and d, c equals 4 and d equals 3.